In this video, I'm going to work out some of the problems with the projectiles that are fired at an angle. So, and we're going to use our formula sheet, our lavender sheet, to do this, okay, or pink sheet. Now, there is a motorcycle jump in a circus. The ramp is inclined at 30 degrees. Okay, so the motorcycle is here. It's going in this direction. Okay, so this is the 30-degree angle. And it's going to make a 30-degree angle with the horizontal. And it's going to go with an initial speed of 20 meters per second. How long will it be in the air? Now, we're assuming that it's going to land at the same height. So it's going to do one of these things here. All right. So the first thing I recommend you do is always trying to find the horizontal and vertical components of this V0, right? So you have a horizontal component that remains constant. There is no reason for it to change. And you have a vertical component that decreases on the way up, becomes 0 at the top, and increases on the way down. I just have to mention this, is that at the very top, the velocity is not 0. The vertical velocity is 0, but the overall velocity is still the horizontal velocity because it's still moving forward. There's no reason for you to stop moving forward, because if the velocity up here was 0, motorcycle will get up to the top and drop. All right, so how long would it be in the air? So I'm going to find the V initial in the x direction, or the components. So this is going to be VO, the cosine of 30 degrees, and this is going to be VO sine of 30 degrees. Now, this is going to be 10 meters per second, and the other one is going to be 17.32. Okay. Now, so initially, it's fired with 10 meters per second up. So without doing much math, we know that it's going to lose all of the 10 meters per second in 1 second, and then it's going to gain another 10 coming back down. So we know that ahead of time that it's going to take 2 seconds. It's going to stay 2 seconds in the air. So let's say if the math confirms that. So when it's coming back down, it's going to hit with the same angle, except that this time it's going to be 30 degrees below the horizontal. So I'm going to try V equals V0 plus AT. Now I'm going to apply this to the vertical motion. So V in the y direction is V0y plus GT. Now, when the object goes back to the same height, its final velocity in the y direction is equal to its initial velocity with a change in sign, because now it's pointing down. The vertical velocity is pointing down. I hope you can see that. So this is going to be negative 20 equals negative 10 t, and we already predicted that the time will be 2 seconds. You could answer the question conceptually. You can just say it's going to take 1 second to get up to the top, to lose the whole 10 meters per second, and it's got to take another second to come back down to the same height. So time up equals time down if you're going back to the same height. It's just like throwing something up in the air. Now, let's look at part B. How far apart must the ramps be? So for part B, so we're looking for delta x, okay? And we're going to use the simple equation, which is V0 in the x direction, not just V0, times time. So in other words, we're looking for this distance here, okay? Now, to find that distance, you have to take into account the whole time, not just the time it takes to get to the top. So this is going to be 17.32 times 2 seconds. And that should be 34.64 meters. Okay. Part C, how high will it jump? So we're looking for this here, which is delta y. So for part C, I'm going to say delta y. Now, there's a bunch of ways you can find this. You can do the one with the time square. And I think we can just do it with the we can do it with the one that doesn't have acceleration in it. So Vy plus V0y over 2 times time. You just have to be careful here. The time it takes to get to the top is only 1 second. So it takes 1 second up and 1 second down. So Vy at the top is 0. Now V0y is 10 over 2 times 1. Okay, and this is 5 meters. Well, we should have predicted this because we know that objects in free fall will drop 5 meters after 1 second. So in other words, if it's here, it's going to drop 5 meters after 1 second. So that should have been predicted. What is the velocity after 1.3 seconds? Now, after 1.3 seconds, we should be on the way down, right? Because at 1 second we're at 1 second we're at the top. So we should be somewhere in here. All right. So let's figure out what which means the Vy should be negative and the Vx will never change. So let's see if we can do part D. Okay. So I'm going to do, well, Vx is just basically 1732. So after 1.3 seconds, let's say we're here. So this is the velocity I need to find, okay? Which means I'm going right and I'm going down. So I need to find the Vy at 1.3 seconds. So I'm going to use this simple equation. V0y is 10 minus 10 times 1.3. And just like we predicted, this has to be negative. So this is going to be negative 3 meters per second. So now, here's your triangle. You're looking for this V here. This is 17.32, and this is negative 3. So but it's 3 going down. And we have to figure out what this angle is. So you do Pythagorean theorem. You can do the inverse tangent, but don't put the negative when you do the inverse tangent. Don't put the negative in front of the 3, and you should get an angle that's about 10 degrees, but you have to say that it's below the horizontal, and the V is 1758, which makes sense because the 3 is much smaller than the 17, so it's not going to affect that speed by that much, and the angle should be small. All right, so let's do 12 we'll do in class. So let's look at 13. Okay. Okay. A football is kicked with an initial speed of 32 meters per second at an angle of 38 degrees. So here's the initial velocity. Okay. And there's an angle of 38 degrees here. So the object is going to go this way and it's going to land somewhere, right? How long is the ball in the air? So we have to find the initial velocities in the x and the y component, in the x and y direction. So this is VO cosine of 38, and this is VO sine of 38. And those answers I have here are 25, 22, and 1970. 25, 22, and 19.70. And you can see that the x has to be bigger. The angle is under 45. So most of your velocity is going horizontally. How long is the ball in the air? Well, you can do this conceptually. You can see that you started with 19.70 and you're going to lose about 10 meters per second every second on the way up. So it should take you about 1.97 seconds to get to the top, the same amount of time to come back down. So it should take you 2 times 1.97. So let's see if the math confirms that. So I'm going to do Vy equals V0y plus GT. Now, when I reach back to this level here, my vertical velocity is equal to my initial vertical velocity but in the opposite direction. That's why I put a negative here. Okay, so this is going to be negative 2 times 19.70. So I'll just write it like this. You can do the math in your calculator. Negative 10t, and if you do the math, you should get 3.94, just like we predicted. Okay. Part B, how high does it reach? So we're trying to figure out this delta y. Now delta y is equal, I'm going to try differently than the number 11. So I'm going to use the equation that has the time square. It's v0 yt. It's not just v0 plus 1/2 gt squared. That's equal to 19.7. Now, you have to be careful here. To get to the top, it only takes half of this time, so which is 1.97. Okay? Minus 5 times 1.97 squared. And if we do the math, we should get 19.41 or 40 meters. So that's how high it's going to go. You could have done it with other equations. How far does it land? So we're trying to find the delta x. So I'm going to say, well, Vx or V0x, that doesn't change, is delta x over time. Delta x equals, now the initial velocity in the x direction, or the component of it, is 25.22 times. Now when it comes to the time, you're trying to figure out the time it takes to cover this whole distance. So that's not just half the time, it's the whole thing. So 3.94, and you should get an answer of 99.37. What is the velocity and magnitude when it hits the ground? Well, vertically, the speed up equals speed down because you're at the same level, and the horizontal velocity never changed. So when you hit in the ground, you're going to hit it at an angle of 38 degrees, except this time it's going to be below the horizontal, and you should hit it with the same velocity you started with, which is 32 meters per second. All right, so let's do 14. You can see that all these problems are pretty much similar. Okay. So the ball is given a velocity VO, 10 meters per second, and the basket is at the same height when he releases the ball. And the angle here is 60 degrees. And so the ball does this, and it just lands back in there. Okay. How much time is left in the game when the basket is made? So we have to figure out how long the ball is in the air, and take that away from 2 seconds to figure out how much time is left on the clock. All right, so V0x equals V0 cosine of 60, and V0y is V0 sine of 60. And if you do the math here, you should get okay, I didn't do that, so so this is going to be 10 cosine of 60. Now cosine of 60 is half meters per second, and then you do 10 sine of 60, and that's 866. Okay. Now if it's 8.66, it should take 0.866 to get to the top and the same amount to get back down. Or we can just do the math. So Vy is V0y plus gt. Now when the ball is here, right, its vertical velocity is the same as its initial vertical velocity, except that it's in the opposite direction. So I can say negative V0y equals V0y plus gt. Okay, and so this is going to be negative 866 equals 866 minus 10t, and the time will be 1.732 seconds. So how much time is left on the clock? You just have to take that away from 2 seconds. So how far from the basket was Mason? So you just have to find the range, basically, the delta x. And the delta x is v initial in the x direction, make sure you do that, times the time that the ball stays in the air. And that's going to be 5 times this time here. And that should give you about 8.66 meters. So in this case here, we're going in this direction, right? So the ball does this. Okay, it's going to land here. Okay. Select the graph from the choices below that best represents horizontal velocity versus time. So I can't see the whole thing. So horizontal velocity versus time. It should be graph. Actually, let me just minimize this. Okay. Still can't see it. All right. That should be graph A, okay? Yeah, because the velocity in the x direction, in the horizontal direction, stays constant, and this graph is showing you that. Horizontal acceleration versus time, well, there is no acceleration, okay, in the x direction, so that should be graph C. And you have to explain, you have to write exactly what I'm saying. Vertical velocity versus time. So vertical velocity versus time. Now here, vertically you slowing down, then you speeding up. So we have to find something that's, I can see all the graphs. So we have to find something that's slowing down and then speeding up. Okay? So that should be graph I. Okay? And the reason for that, telling us to use up as positive. If they didn't tell us that, the answer could also be D. So this can be both correct. If they had said that up is negative, then we'll have to go with D. Okay? And the next question is the vertical acceleration versus time. Well, the acceleration is going to be negative on the way up and it's going to be negative on the way down. So that should be graph B. And basically, I'm not going to write the explanation, but pretty much whatever I'm saying is the explanation. That's what you should be writing. Okay. So we're given these scenarios. I think the angles are the same, and they have different speeds. So you just have to keep in mind that those masses are just distractions in there, so they don't matter. Rank the maximum height the arrows will reach. Okay. So the maximum height that they're going to reach all depends on their initial vertical velocity, right? So in other words, if you throw with a high initial velocity vertically, you're going to go high. If you throw with a small velocity, you're going to go low. So I think the C will be first, because your initial vertical velocity has to be bigger, because the angle is the same in all of these cases, and then comes B, and then A, and D are a tie, and they are last. Okay. All right. A ball is projected with an initial speed of 32 meters per second at an angle of 30 degrees with the horizontal. All right. So same picture every single time. Okay. So the first thing I want to do is I want to find my components of my initial velocity, both in the x direction and in the y direction. So this is going to be 32 cosine of 30, and this is 32 sine of 30. I know that this is a 16, because sine of 30 is half. The other one I don't know, so I'm going to use a calculator. 27.71. Okay, and it's and you can see why that the x has to be bigger, because the angle is closer to the horizontal. So in other words, it's below 45 degrees. How much time does it take to reach the top of the path? See, now it doesn't say how much time it spends in the air. We're just looking at the time it takes to get up to this point here. Now we can do this just with the definition of acceleration. We're going to lose 10 meters per second every second. So I think to lose the whole 16 meters per second, you're going to need 1.6 seconds. All right, so let's see if the math can confirm that. The Vy equals V0y plus gt. Now at the top, the vertical velocity is 0. And the initially started with 16 minus 10 times t. And just like what we predicted, or we answered conceptually, it takes 1.6 seconds to get to the top. Find the horizontal distance. Now, delta x is the initial velocity in the x direction times time. Now, you just have to be careful. This time here is the time for the whole trip, up and down. So it's not 1.6. It's twice as much, because time up equals time down. So this should be 27.71 times 2 times 1.6. So you just got to be careful with that. And you can put that in your calculator. All right, I'm going to do a 16 up here. It's kind of similar, but really. How much later does it hit the ground? So I'm just going to go with Vy equals V0y plus gt. Now, when it hits the ground, the vertical velocity is the same as the initial vertical velocity, except that it's going down. So there is an opposite sign here, a minus. Okay. Now, the V0y, I think, is just 21 sine of 37, right? And once you move this over to this side, you're going to have 2 of them, just like that, okay? Equals negative 10 times t, and you can get your time to be 2.53 seconds. Okay. A golfer hits a ball with an initial speed of 29 meters per second at an angle of 40 degrees above the horizontal. Calculate the time in the air. Again, same story. Okay, so you can take a look at the previous ones, and you can see that, well, when it hits the ground, its vertical velocity must be equal to its initial velocity in the vertical direction, right? Except with the difference in sign. So it's negative V0y equals V0y minus 10 times t. Now, V0y is 29 sine of 40, but since if you move this to the left, it's going to become negative 2 times as that much. Okay, equals negative 10 times t, and your time should be 3.73 seconds. Now that's the time it spends in the air. And that's the time we're going to use to find the range. Okay, so delta x is the initial velocity in the x direction times time. The initial velocity in the x direction is 29 cosine of 40. If you can't see that, go back to the previous problems. And the time is 3.73, and you get the answer that's in the answer key. All right, let's look at the next one. An athlete executing a long jump leaves the ground at an angle of 30 degrees with the horizontal, that is, with the speed of 10 meters per second. Calculate the horizontal distance traveled. Okay. So I'm looking for delta x. Now that's going to be v0 in the x direction times time in the air. So that's going to be 10 cosine of 30. Now I don't know the time that it stays in the air. So I have to rely on the y direction. So I'm going to say, well, Vy when it hits the ground is equal to the initial velocity in the y direction plus gt. But when it hits the ground, vertically it's traveling at the same speed it had when it first started vertically, except that it's in the opposite direction. So it's the same speed, opposite direction. Now this is going to be, if you move this v0y to this side, it becomes negative 2 v0y, and v0y is v0 sine 30 degrees. I hope you can see the algebra. If you can't, figure it out. All right? Okay. So the algebra should not be that bad in here. And once you get that time, you just plug it in here and you're good to go. Okay. All right. A rocket is launched at an angle of 50 degrees above the ground. It takes 2.8 seconds to reach a height of 190 meters. What was the rocket's initial velocity? Now, one thing you don't want to do here, do not assume that 190 meters is the highest point reached. It just says that it reaches that height after 2.8 seconds. So nothing says that it's the highest point. So V initial, we don't know. And this is 50 degrees. Okay, so it does this, it does its thing, and it lands there. What was the rocket's initial velocity? So I think if we just use delta y equals v0 yt plus 1/2 gt squared, that should get us there. Now the delta y is a positive 190 because it's still above where he started. Okay, equals, so what I'm going to do, I'm going to find the v0y and then come back here and figure out what the v0 is. And this is 2.8 minus 5 times 2.8 squared, which gives us an initial velocity in the y direction equal to 81.86 meters per second. Now if you look inside this, this is VO, this is the x component, and this is the y component. And this 50 degrees. So it looks like it's VO, it's got to be equal to V0y over sine of 50. I hope you can see that. That's opposite and hypotenuse, right? And that should give you about 106.86 meters per second. So the only tricky part about this problem, do not assume that 190 meters is the highest point just because it says it reaches a height of 190 meters. So a lot of people do that. I noticed that over the years. Okay. The next thing we're going to do is this rockets problem. Okay. So the angle is the same, but they have different speeds. So again, the mass is just a distraction. Rank the horizontal speed of the rockets at the maximum height. So the horizontal speed is just going to be, since they have the same angle, the one that's going to have the highest speed is going to have the highest horizontal speed. Their vertical speeds will be 0, right? So the horizontal speed is just going to be the initial speed cosine of some angle. But since the angle is the same, right, to compare their horizontal speed at the top, which really is the same, doesn't change throughout the problem, you just have to figure out which one has a higher overall speed. So it looks like D comes first, followed by A, and then B, and C are a tie for last place. Okay. All right, let's look at this cannon problems here. So now the angles are different. The velocity of each cannon as it leaves the cannon is given. So these are also different in some cases. Okay, along with the horizontal component, which is the same. Okay, so the horizontal component is the same. Rank the horizontal distance traveled by the cannonball. Now, to find the horizontal distance, that's VO in the x direction times time. So now this VO in the x direction is the same for all of them. So now, to figure out the delta x or the range, it's going to come down to the time spent in the air. All right. So it looks like you have to figure out the y component of this velocities, basically. Okay, these y components, and the one that's going to have a higher y component is the one that's going to stay in the air longer, and the order is okay, so that's going to be the order after my calculations is D, B and C are tied. Yeah, because these have the same angle, and okay, and then comes A last. Okay. I'm just trying to see if there is a quicker way of doing this. Okay, so we just have to find the y components and compare them. Okay. A ball is thrown with a speed of 123 feet per second, so we have to change that to meters per second, and that's about 37.5 meters per second. Find the time of flight. So we've done a bunch of this now until now. So it does something like this: flies, lands at the same height, and the angle here is 30 degrees. Okay, so I'm going to say, well, Vy equals V0y plus GT. Now, we need length. It's horizontal. I mean, not horizontal. It's vertical. Velocity is equal to its initial vertical velocity, but it's going in the other direction. So I have to change that. So this is going to be -2 V0y, which is 37.5 sine of 30 degrees. I hope you can see this by now. -10 times t. And that should give us 3.75. Is it 3.75? Yeah. Yeah, 3.75 seconds. So that's the time. Okay. How far did it land? Well, we're looking for delta x, so that's V0 in the x direction times time. Now, the V0 in the x direction is 37.5 cosine of 30, and the time is whatever time we got here. And that should give us 121.78. Find the maximum height. So we have to find this distance here. So I can probably use a bunch of equations. I'm going to go with the easiest one. Okay. Now, these are all in the y direction. So Vy, V0y. At the highest point, Vy is 0. Okay. So delta y is equal to V0y, which is going to be 37.5 sine of 30 divided by 2. Now, this is where you have to be careful. It takes half of this time to get to the top. So you have to take 3.75 and divide it by 2. and you will get an answer of 17.58. All right, we're looking at 21. So Lizzie hits a volleyball with an initial velocity at an angle above the horizontal. The ball reaches maximum height after 1.5 seconds, and it traveled a total distance of 6.3 meters. So basically, the ball is going to be in the air for 3 seconds. What was the initial velocity of the ball? So it's basically like this. Here is the velocity. There is a certain angle here, and the ball is going to do this, and it's going to land here. Okay. And obviously, since it's a volleyball, it's going to continue, but we're just going to say that this height here is reached after 1.5 seconds. So we have to find the initial velocity in the x direction, and we have to find the initial velocity in the y direction. So at the peak of this path, right? So I can say that Vy equals V0y plus gt. Now at the top there, this is 0, and V0y is 0 equals V0y minus 10 times t, I think, is 1.5 seconds. So V0y is basically 15 meters per second. Now to find the Vx, which is really the same as V0x because the horizontal velocity doesn't change, we're going to say that's delta x over time. Now the time here is not 1.5 because delta x is the whole range, this whole distance here. So this is V0x equals delta x, which is 6.3 divided by 3 seconds, so which is 2.1 meters per second. So this is what we're looking at. This is the VO. Your x component is 2.1, and your y component is 15, and we're looking for this angle here. So if you do a little bit of trick, you should get a velocity of 15.15 and an angle of 82 degrees above the horizontal. All right, let's look at 22. Okay. So pretty much the information is given here. So this initial velocity is 105 meters per second, 105 meters per second. Determine the time taken by the projectile to hit point P at the ground. So to get here. So now I think if you try, you can look at all your equations. The only equation that actually will cut it for you is the one that has the time square. This one right here. Now, the delta y is negative 125 because it's starting here. So this is your origin for the y direction, okay, and for your x direction also. And anything above this point here is positive, and anything below is negative. So your displacement is negative. Equals 105 sine of 37. Maybe I should have found V0x and V0y first, but that doesn't matter. Okay, and we're looking for time, minus 5t squared. Now you can do quadratic equation. You can use your graphing capabilities of your calculator, but you should get 14.38 seconds for the time. Now for part B, determine the range. So in other words, we're looking for this big X here. They're calling it X. So X equals V0 in the X direction times the time it takes to go across this distance here, which is 14.38. So this X is 105 cosine of 37 times 14.38. And you should get an X equals to 1205.86. Okay, meters. Okay. For part C, find the velocity at impact. In other words, when we hit in here, what is that velocity? Now keep in mind that it's coming at an angle, so we have to find the x component and the y component. Well, luckily the x component, the Vx, does not change. Is whatever we got from 105 cosine of 37. So 105 cosine of 37 should be I'm looking. All right, I don't have that here, so I'm going to try it. So 105 cosine of 37, so that's 83.86. Now, with what speed does it hit the ground vertically? So we have to find the Vy. And I think the best way is to do V0y plus GT. Now, the V0y is 105 sine of 37 minus 10 times 14.38. And Vy will be, hopefully I have this here, it's negative 80.61. And it makes sense because you're hitting vertically, you're going down. Okay. So now to find the speed here, so if I take this velocity, here is the V, here's the X component, and here's the Y component. Okay, so this X component is 83.86, and the Y component in magnitude is 80.61. So this is the angle. You should see that the angle is close to 45, and the reason for that, because those two sides are almost the same. Right, so it's going to be a little shy of 45, as a matter of fact. Okay, so the V will be 116.32 if you do Pythagorean theorem, and if you can do one of your trig functions, probably inverse tangent or whatever you want to do, you should get about 44 degrees below the horizontal. All right, the last thing we're going to do is we're going to find the total vertical distance traveled. Okay, so in other words, we're going to find the distance that it does up to here, double that, and add 125 to that. So let's figure out the distance, the maximum height that it reaches. So for that, I think I'm going to do Vy square is V0y square plus 2g delta y. Well, at the highest point, it stops moving vertically. V0y, you can find that. That's 63.19 minus 20 times delta y, and you get a delta y equal to 199.65. So you double that, and you add 125 on top of that, and you should get 524.30. Okay, let's look at 23. A projectile is launched at an angle of 50 degrees and lands 110 meters away. Find the initial speed of the projectile. Okay. So this is the initial velocity. That's what we're looking for. This angle here is 50 degrees. So it does something like this. And it lands here. So, and this range is 110 meters. Now, I'm going to do this a little bit differently than what I did the proofs to when I did the range equation without the time. I'm going to do it a little differently this time. What I'm going to do is that I'm going to find an expression for time in the vertical direction, and I'm going to find an expression for time in the horizontal direction, and maybe set this equal to each other. So in the vertical direction, by the time you come back to here, your Vy is basically your initial velocity in the y direction, but in the traveling down in the opposite direction with the negative sign. So basically, if you can't follow here, what I'm doing is that I'm doing Vy equals V0y plus AT plus GT, basically, right? So the time here is equal to negative 2 V0 sine of 50. I hope you can see that over G. Okay. Now let's do the same thing in the horizontal direction. Now V0x is delta x over time. Time is equal to delta x over V0 cosine of 37. Now all you have to do, the time is the same, so you have to set this 2 times equal. So you should end up with negative 2 V0 sine 50 over g, which is negative 10, equals delta x over v0 cosine of 37. Now, you figure out how to solve this equation. You have the delta x, you have the g. Oh, not 37. Did I say 37? No, the angle is 50 degrees, sorry. 50. I'm still remembering the angle from the previous problem. And you can find the v. So this is just a different approach than what I did with the in the last video. Okay. Projectile is launched from, we're at 24, from the top of a cliff with a speed of 22 meters per second and an angle of 30 degrees above the horizontal, and lands 100 meters from the base of the cliff. How long was the projectile in the air? Okay, so this is basically, this is the cliff. So it lands down here somewhere. And this initial velocity is 22 meters per second. And this angle here is 30 degrees. And the range is 100 meters. Okay. How long was the projectile in the air? So in order to do this, I think you can look at all your equations, but I think the only one that's going to cut it is the one that has the time square in it. Okay. Actually, we don't have the delta y, so we have to rely on the delta x. Yeah, that's what we have to do. So v0 x equals delta x over time, because the other one won't cut it. So this is going to be 22 cosine of 30, that's the x component of the VO, equals 100 over time. And if you do the math here, you should get a time equal to 5.25 seconds. So this is part A. Part B, how high is the cliff? So we're looking for this height here. So I'm going to have to work with delta y equals v0 yt plus half gt squared. v0 y is 22 sine of 30, should be 11, times t, which we found earlier to be 5.25 seconds, minus 5.25 seconds, square. And if you do put this stuff in your calculator correctly, you should get 80, or negative 80.06, which means the cliff is 80.06 meters high. Okay, the last one is so we did, okay, how high is the cliff? How long was, okay, we did that. So that's how high is the cliff, how high above its original position did it rise. So let's try that. So we're trying to figure out this delta y here, which is very different than this one here. So at this point here, your vertical velocity is 0. So I'm going to use the one that doesn't have the time square, the time period. So plus 2g delta y. At the top, your vertical velocity is 0. And the v0y should be 11. In other words, it's 22 sine of 30 minus 20 delta y. And if you do the math correctly here, you should get delta y equals 6.05. All right. All right. Jeff Mittich, this is one of our soccer players, takes a soccer free kick 20 meters from goal with a speed of 36 miles per hour. So we have to figure out what 36 miles per hour is. 36 miles per hour is about 16 meters per second. So let's draw the scenario here. So here is the initial velocity, which is 16 meters per second. The angle is 30 degrees. Okay. The human wall is 9 meters away from the ball. Okay. So the wall is here. So there's a, if you know soccer, you know that you have to put a wall in front of the kick if it's close to the goal. All right, so this distance here is 1.8. So a bunch of tall guys get in the wall. Okay, will the ball clear the wall? So this distance here is 9 meters. Okay, so I'm not sure whether it's gonna not clear the wall or if it's gonna clear the wall. And the net is somewhere here. So Bernard is in the net. All right. Will the ball clear the wall? So what I think we should do is figure out what the delta y is here when the object or the ball has traveled 9 meters horizontally. So I think I'm going to find the initial velocities or the components of the initial velocity in both directions. So this is going to be 16 cosine of 30. This is going to be 16 sine of 30. Now this one is 8 meters per second, and the one in the x direction is, what is it? 13.86. So let's figure out the time that it takes to travel 9 meters horizontally. Use that time to figure out the height after traveling this 9 meters. So I'm going to say Vx or V0x is delta x over t. So which means t equals delta x, which is 9, over the x component of the initial velocity, 13.86, and we should get a time of 0.65 seconds. Okay, so basically it's going to take 0.65 seconds to get to the location of the wall. Now whether it's going to clear it or not, we'll have to find the delta y after this much time has passed. Okay. All right. V0y is 8 times 0.65 minus 5 times 0.65 squared. So the delta y is equal to 3.09 meters, and that's greater than 1.8 meters, which is the height of the wall. So the ball is going to clear the wall. So the next question is, well, will it go in? Is it going to be a goal? Assuming that the keeper doesn't get it. All right? Okay, so this distance here is, what is it? 20 meters. We'll redo the same process. Okay, so we do, instead of 9 here, we put 20, right? And the time should be 1.44 seconds. Okay, and you do the same exact thing here. So you put in 1.44 for time, and you should get a distance or a height equal to 1.13. Okay, now that's between 0 and 2.5, which means the ball went in, assuming if the goalie could not save it. All right, 26. Okay, a projectile is launched from ground level to the top of a cliff, which is 195 meters away and 155 meters high. If the projectile lands on top of the cliff, now with problems like this, never assume that actually the highest point is right where the cliff is. So it does, based on the picture, kind of it looks like it reaches the highest point there. So it does something like this. Okay. Find the initial velocity of the projectile. So I think we should find the velocity in the x direction, the velocity in the y direction, and just combine them to find the initial velocity. So I'm going to say v0x equals delta x over time. Okay. So which means which is equal to 195 over 7.6 seconds, which gives me 25.66 meters per second. Now, to find the velocity in the in the y direction, we're going to find the initial velocity, the vertical component of the initial velocity. So I'm going to use delta y equals v0 yt plus half gt squared. Okay. Now this is 155. That's positive because you're going to end up above where you started. So that's a positive displacement. v0y, you put in 7.6 for time in both parts. Okay, and if you solve this equation, you get an initial vertical velocity equal to 58.39. 58.39 meters per second. So this is what we're looking at. Here's your initial velocity. The x component of that is 25.66, and the the vertical component is 58.39. So we should end up with an angle bigger than 45 for sure. Now, if you do Pythagorean theorem, you should get your VO, and if you do one of your trig functions, you get the angle. And the answers are in the on haiku. Okay. Now let's look at this cannonball problems. All right, so they're giving us the vertical velocity and they're asking us, well, rank the time that the cannonballs stay in the air. Since they all have the same initial vertical velocity, they have to stay in the air the same amount of time. As a matter of fact, for all of these problems, the ball should stay in the air for about 4 seconds, because every second is going to lose 10 from the 20. So it's going to take 2 seconds to lose the whole 20, and then it's going to pick up the 20 again after 2 more seconds. So it's going to take the same amount of time, okay, for them. They're going to stay the same amount of time in the air, and that should do it. All right, I'm out. Peace.